Now for exercise number 5, I know that the wording is a lot more than this, but at the very end, they're essentially telling us to evaluate this integral. They're even giving us a hint. So let's do that. We'll make this substitution in there, and we'll evaluate this integral. So we have integral 0 to 2 pi. We have a square root 2, 1 minus something d theta. What goes in here? Cosine. What can cosine be replaced by? A great many things. But in this context, we'll use this in there. 1 minus 2 sine squared of theta halves. Now, why don't we drop a 1 here and distribute? So we have 0 to 2 pi. Those being our limits of integration, it'll be 1 minus 1 plus 2 sine squared of theta halves. D theta, 0 to 2 pi, square root 2. The 1's are gone, and so it'll just be 2 times 2 sine squared theta halves d theta. So this is 0 to 2 pi. Check it out. That's going to be the square root of 4. So we have 4 sine squared theta halves d theta, 0 to 2 pi. So look, the square root of 4 is just 2. The square root of sine squared is just sine. Keep your theta halves the same. If you want, we can pull out the constant to the front. Let me be less sloppy. And we have sine of theta halves d theta. So look, the 2 just goes along for the ride. What is the antiderivative of sine? It would be negative cosine. We keep this the same. So watch, let's go backwards if you want. What is the derivative of negative cosine? It would be positive sine. But if I take the derivative of theta halves, there will be a 1/2. So you know what? You have to put a 2 there. Because if I take the derivative of this, it will be exactly that. You can work that out if you want to. This derivative is that. This derivative is that. However, there is still a 2 that is being multiplied in the front. And so this is the antiderivative of that, and we will evaluate it from 0 to 2 pi. And so this is basically negative 4 cosine of theta halves evaluated from 0 to 2 pi. So let's evaluate this integral here on this scratch piece of paper. So plug in 2 pi into theta. So we have negative 4 cosine 2 pi over 2 minus, and then plug in 0 into that. It'll be negative 4 cosine 0 over 2. I should put equals, 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 equals. So this would be negative 4 cosine of pi plus, because of the double negative, 4 times the cosine of 0. So this is negative 4. Cosine of pi is negative 1 plus 4 times cosine of 0 is 1. So our final answer is 8. So this is the value of that original integral.